So I just watched an awesome video by my friend Rhett, and he was doing a bead on a parabolic wire. And so I put a comment about how often students will say, well, the potential energy is quadratic, so I expect this to be simple harmonic motion, but it really isn't. So, so let's talk about what we're saying here. So plot, x squared as x goes from minus, I don't care, 10 to 10 or something. Right, so we're talking about a wire, whoops. We're talking about a wire that looks like that. And let me make this so that you actually see what it looks like. Yeah, so now 1 unit horizontal is 1 unit vertical. And so this would be boom, 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 swooping all around. What I want to do is take a look at what this, well, let me make everything a little bit bigger, maybe 150%. There we go. What I want to do is solve this and show that if you start things at different points, they don't have the same periods. So if I say y of x, no, y of t is, well, I need to divide some things. Let's have a equals, I don't know, 1 or something. M equals 1, g equals 9.8. What else are we going to need? That's probably it. I'm going to say y of t is a times x of t squared. Cool. And then I'm going to say that the kinetic energy is 1/2 mass of x prime of t squared plus y prime, oh, come on, y prime of t squared, like so. And the potential energy is just going to be mg times y of t. Cool. My Lagrangian is just the kinetic energy minus the potential energy, and I really only have one variable, so I can just jump right to it. So sol equals first and d solve. Let's see, I need d of L with respect to x of t minus d of L with respect to x prime of t with respect to t equals 0. And let's have x of 0 equals 1. Let's have x prime of 0 equals 0, so it starts at rest. Please solve for x. And let's have t go, I don't know, 10 seconds into the future or something. And then let's, I'll just run that. Okay, so it looks kind of nice and sinusoidal here. It's my argument that it's not. So what I want to do is actually, you know what I'm going to do? I'm just going to copy this. I'm going to cut it out, and I'm going to say sol function, which is a function of initial x colon equals, and paste it all in here. And all I'm going to do is put that right here, initial x. Okay, so now if I do plot, parametric plot, is that what I want to do? No, let's do plot x of t slash dot sol function 1 as t goes from 0 to 10. Let's see if that works. Oh, it's not happy. That is not a happy camper. Okay, so I'm just going to quit the kernel here. Figure out what I did wrong, because I think I defined something. Yes, really and truly quit the kernel. I want to see if this actually works. So if I do, waiting for the kernel to restart, some function of 1, what happens? I'll just pause the video until it's going here. Okay, so it finished. So that works. So what I can do, here, let me just do this. Sol, oops, get my cursor in the right place. Sols equals table, sol function, I as I goes from 1 to 10. Okay, so now they're all been run. So now let me do this. Evaluate, so they're different colors. X of t slash dot sols I as I goes to the length of sols. There's a better way to do that, but that'll work. Oops, I need a table in here. Let's try that. Yep, they all have different periods. You can see it. They're all over the map here. So this high one really takes forever. It doesn't even experience it. It's really just half a period, whereas this low one does like 5 or 6 periods. So this is definitely not simple harmonic motion. How to prove that? Because when we say, oh, well, my potential energy is just, well, if I just ask what the potential energy is, it looks like it's quadratic. But the problem is, if I do the equation of motion, this is exactly what Rhett was doing in his equation. If I just put that out, let me simplify that. I mean, you definitely don't have simple harmonic motion, which would have been a single x double dot term and a single x term. Well, why? It's because the path, right? The path that's actually going on is this. So its journey is in two-dimensional space. It's literally not just moving left and right. It's actually moving up and down. And so you don't actually have simple harmonic motion here. All right. Have a great day.